This is number 3 on the chapter 3 review, and it asks you to graph a sketch of this equation. So the first thing you need to realize is 90 divided by 1 plus 271 times e to the negative 0, all of that, yeah, all of this junk, is a logistic function. And we know a logistic takes the shape of an S. Okay, so it has two asymptotes. So we first need to find the first asymptotes. Well, if you remember, the actual equation for a logistic is y equals c over 1 plus a times b to the x. In this case, my base is e. C is my carrying capacity. That means it's as big as we can get. Okay? So we know there's going to be a horizontal asymptote at our carrying capacity at 90. So since it's just a sketch, I'm going to draw my horizontal asymptote and say, hey, this is y equals 90. We also know, since it's logistic, and one of the properties of logistic is the smallest it can ever be, or even get close to, is 0. So we have these two asymptotes, y equals 90 and y equals 0. So then to graph this, we know it's going to make some S shape. It could also look like this and go the opposite way. So what we first have to do is find our y-intercept. So to find your y-intercept, remember all you have to do is plug in 0 for x, because no matter what, wherever you cross the y-axis, x is equal to 0. So I'm going to take my entire equation, and instead of x, I'm going to replace it with 0. So I'd get 90 divided by 1 plus 271 times e to the negative 0.122x, but x is 0. So then when I go to evaluate this, you got to do your order of operations first. Which remember is please excuse my dear Aunt Sally. So parentheses, I have none. Exponent. So I have to do my exponent first, and within my exponent, I have multiplication. Well, when I take negative 0.122 times 0, that's 0. So then I'm left with 90 divided by 1 plus 271 e to the 0. Well, if you remember, e to the 0, well, anything to the 0 is 1. So I get 90 divided by 1 plus 271 times 1. Well, 271 times 1 is 1, plus 1 is 272. So I get 90 divided by 272. And that's kind of a nasty fraction. You could simplify it, or if you type this into your calculator, it's about 0.33 something. So my y-intercept is about that. So I'm going to go over to my graph. Sorry, I'm kind of moving this. What the? I think somebody's outside my house and it's kind of creeping me out. But anyway, so this is my y-intercept. So I'm going to graph that. Again, it's just a sketch. We have to label it, so it's 0.33. Now, I have to figure out if it's going to start up here or down here. Okay, and then I have to find out if it's going to end here or here. Well, you only really have to do one limit, and I think it's easier to think of limits as a big number. So I'm going to do the limit as x approaches infinity, so as x gets really, really big, of this whole function. Oh my goodness, we'll write it out. It's really long. Oops, I forgot my one. Okay, so let's think about this. As x gets really big, well, if x is 0, we already know it's this, right? If x is 1, big, it keeps getting, so let's just kind of look at this part, because this is where we're plugging in x to. Okay, so that's where we're going to zoom in for a second. I have e. Well, e is kind of a hard number. Remember, it's 2.718. Even that's kind of hard. So I'm going to just imagine, because it's going to be very, very similar to when e is 3. So I'm going to imagine 3 to this negative 0.122. So x, what we can do is think about when it gets really big. So when x is 10, this is the same as 3 to the negative. If I multiply this by 10, it moves over 1, 1.22. Multiply it by 100, I get 3 to the negative 12.2. Multiply it by 1,000, I get 3 to the negative 122. Okay, so that's what's kind of going on. Oh, you can't see it. Sorry, guys. That's what's kind of going on. I'm just zooming into this part, thinking, okay, what's happening as x gets really big? Well, if we look at this, this is the same as 1 over 3 to the 1.22, 1 over 3 to the 12.2, 1 over 3 to the 122. So as x gets really big, these are actually getting really, really small. So as x gets bigger and bigger, this is getting closer to 0. So then if we look at this limit, okay, we know that's getting closer to 0. Well, 0 times 271 is 0, plus 1 is 1. So my limit goes to 90 over 1. Because again, as this got really big, my x's got really small. It gets smaller and smaller. And then all of this will go to 90 over 1. So that means as x goes to infinity, I'm going towards 90. So that means it's going to go at the end up, which means at the bottom it's going to go down. Okay? So you just have to think what's happening when it gets really big. You can just plug in numbers, 10, 20, 30, 40. I usually do 10, 100, 1,000, stuff like that. And realize this is getting really small really fast. So it's getting closer to 0. So that ends up canceling out and you get 90 over 1. So that's your sketch. Happy studying.